Dear students, today we will discuss microprocessor, that is 8086 microprocessor. Microprocessor is a programmable logic device. It can perform arithmetic and logical operations. The 8086 microprocessor. The Intel 8086 is a 16-bit microprocessor that is used as the CPU, Central Processing Unit, in a microcomputer. The 8086 microprocessor has a 16-bit data bus, so it can read data from or write data to memory and ports, either 16 bits or 8 bits at a time, that is during one clock cycle. 8086 microprocessor has 20-bit address bus. So the memory capacity of the processor is equal to 2 to the power of 20 is equal to 1 megabyte of memory. The memory capacity of any processor is equal to 2 to the power of n, where n is equal to number of address bits. Therefore, the memory capacity of any processor depends on the number of bits. 16-bit data will be stored in two consecutive memory locations. If the first byte of a word, that is 16 bits, is at an even address, the 8086 microprocessor can read the entire word in one operation. If the first byte of a word, that is 16 bits, is at an odd address, the 8086 processor will read the first byte, that is 8 bits, with one bus operation, and the second byte with another bus operation. The Intel 8088 processor has the same arithmetic logic unit, same registers, and same instruction set as the 8086 processor. The 8088 processor also has a 20-bit address bus, so the memory capacity is also 1 megabyte. However, 8088 processor has an 8-bit data bus. Therefore, it can only read data from or write data to memory and ports 8 bits at a time. The 8086 processor can read or write either 8 or 16 bits at a time. Look at the internal block diagram of 8086 processor. The 8086 processor or 8086 Central Processing Unit is divided into two independent functional units, which are the Bus Interface Unit BIU and the Execution Unit EU. Bus Interface Unit. The Bus Interface Unit sends out addresses, fetches instructions from memory, reads data from ports and memory, and writes data to ports and memory. That is, the bus interface unit handles all transfers of data and addresses on the buses for the execution unit. Bus interface unit has 4 segment registers, which are extra segment register, code segment register, stack segment register, and data segment register. The segment registers are used to hold the upper 16 bits of starting address for 4 memory segments. Bus interfacing unit has also instruction pointer. The instruction pointer register holds the 16-bit address or offset of the next code byte within this code segment. The bus interface unit has also 6-byte instruction queue So it can fetches up to 6 instruction bytes. The bus interface unit stores these pre-fetched bytes in a first in first out register set called a queue. Fetching the next instruction while the current instruction executes is called pipelining. Fetching the next instruction while the current instruction executes is called pipelining. Execution unit. Look at internal block diagram of 8086 processor. The execution unit has 8 general purpose registers which are AH, AL, BH, BL, CH, CL, DH and DL. These registers are capable of storing 8-bit data. The AL register is also called the accumulator. It has a special feature that the other general purpose registers do not have. The pair of general purpose registers can be used together to store 16-bit data bits. The acceptable register pairs are AH and AL pair is referred to as AX register, that is 16 bits. BH and BL pair is referred to as BX register. CH and CL pair is referred to as CX register. DH and DL pair is referred to as DX register. So if we need 16 bits, then we have to go for AX, BX, CX and DX. These registers are capable of storing 16 bits. Execution unit also has a pointer and index registers as shown in the internal block diagram of 8086 processor, which are 16-bit stack pointer register, 16-bit base pointer register and 16-bit source index register and 16-bit destination index register. The three registers, base pointer, source index and destination index, can be used for temporary storage of data just like the general purpose registers. However, their main use is to hold the 16-bit offset of a data word in any one of the segments. Stack segment register and stack pointer register. A stack is a section of memory set aside to store addresses and data while a subprogram is executing or running. Stack segment register is used to hold upper 16 bits of starting address, and stack pointer register is used to hold the 16-bit offset.